Hi and welcome to this video that is a continuation of the previous videos that we did on that we worked with this face in Gazebo, and we learned how to connect it to Raspberry Pi. We also learned how to do text-to-speech. We also did some movement and some face landmark detections. So in this video it's just like an add-on on what we've done until now, and what we are going to learn is how to use all this landmark detection data to move our face to try to mimic what we're doing. So if we open the mouth, it will open the mouth. If we move the head around, it should move the head around. Okay, with its problems, with it, it needs to be perfected and so on. But basically, we're going to learn the basics of how to do it, and in the next video, we are going to try to do it a bit better. So let's get started. So as you can see, the difference between the face that we had in previous videos and this one is that we have divided this face in around the mouth. So this has been done in Blender. So if you want to learn how to do it, please leave in the comments below, and I'll try to do a tutorial about it. But basically, I've just got the mesh and split it in two parts, and that's it. Okay. So what I'm going to show you is how to add that modification to our existing code with the chakra model for Gazebo. So first things first, as always, we're going to use ROS Development Studio for this, which is a web-based development platform for ROS, and we are going to work on our previous project. So we are going to open the IDE, and here, let's have a look. So if you remember, we had, this is from like the first videos that we did. We had in, this one, there we go. This one, MagicMirror description. So here we had a chakra file that defined everything, which was MagicMirror chakra. And what we've done to do this new face with this articulation here is I've created a new chakra which is basically the same, but we are not using the same face, the face chakra. We've done the face actuated chakra. The rest of the things are exactly the same. This is one of the good things about using chakras. You can recycle your code, which is amazing and very practical. So you go to face, let's have a look what we've done. It's essentially the same. It's the same, just that I've added a new joint with a new transmission and so on. So if you go down, you'll see that I've added this new link, which is called mouth link. And obviously I've added a new STL, which is the STL for this part. And also due to this, I've also had to modify the face one. So you see that it's another STL, which is face split face. Obviously we have to change. Okay. And what you have to do is add this link, which is a very basic link with meshes for collisions and for visuals. And I've added some mass and some size for the inertias, which is based like the previous one in the bounding box you can find in Blender for the model. And the mass, I've just lowered it down to the minimum. So if you go to common properties, you can see that the mass is 0.001, but also I've lowered the face mass because If you remember when it moved really slow. And one of the reasons was that it was really heavy. So basically because it's like a virtual face, we don't need it to weigh 1 kilo. So I've just added a minimum amount of mass, and that's it. So it moves much faster now, which allows us to track and try to mimic the facial expressions better. So if we go back, it's basically a link with a gazebo, like always, and we added a joint, which is prismatic. This is the new thing. It's prismatic because it has to go up and down. And then we just link it to the face. And we add some lower and upper limits. This limit is just to avoid that the mouth goes like way open, because it wouldn't have any sense at all. And then the force, which is really high to allow it to go very fast. And that's it, without damping. This is very important because if you damp, then it goes slower, which again, for mimicking facial expressions and tracking it, it's really annoying because it won't go as fast as we want. And then we put up a transmission. Yeah, this is for the first part of what to do to adapt it to make it look like this and move. Okay. Oh, I forgot. Also, you have to add a new control, of course, because you have to add a new joint. And what I've done is added some differential. If you add some differential, then it goes really fast and to the position that you ask, okay? It's just that. It was just tuning it a bit. Yeah, this is one of the parts that I had to explain. Then the good part, no? It's how to get the distance to send to this joint so that it mimics more or less when I open the mouth, it opens the mouth, and when I close it, it more or less closes it, okay? So let's go for it. So what I've done is here in the MagicMirror description, I've done created two files. One is to move, like the actuators, which we'll see in a minute. And this one, which is read face landmarks, move mirror head, okay? Which, what it does is, it's a class, okay? And what it does is, essentially, we subscribe to the face landmarks array that were published in the previous videos, which has all the data of all the landmarks of the face detected. And we just look for the mouth 3 and mouth 9, which would be like this point here in a mouth and this one here. So the upper lip center and the lower lip center. And we calculate the distance. We'll see that in a minute. So basically we do a subscriber for this face landmarks array. And then we will publish in the topic the mouth distance. So if we go to this callback, here, essentially what it does is, there we go. So what we do is we read each message from this face landmarks array, which it has all the points. If you remember in the previous video, it was the RViz that we saw all the points moving and tracking the face. So basically it's getting that data and looking for these two through this face part number to name. Let me show you here. Yeah, so this one converts the data that we stored, which was in numbers. So for example, mouth would be 100 and the first point would be 101, second point 102, let's have a look at the, because I think you'll, well, no, just let's see, let's explain it then. Okay, so this converts to, again, the names, and once you have it, you see that this one, you get the name, which would be like mouth 7, for example, and then goes inside this update mouth points and takes this, and if the name is mouth 3 or mouth 9, like this, then it adds it, it updates its internal dictionary, which we store the data of only those 2 points. If it's not, then it won't do anything. Okay? Yeah. So once you have that and you have it dated, then always when a callback, then we publish the mouth distance, which what it does is calculate the distance and publish it. So first checks that in the dictionary, internal dictionary, it has the 2 points like this, mouth up, which is this one, mouth down, yeah. And once we have it, then we calculate. So we access the points. Yeah, like here and here, sorry. And then we calculate just a distance. And then we publish. And here we have the distance between the lips. That's the main fact. And that's quite it. Once you have that, we'll have a topic which is called mouth open distance, which we will read to move the mouth. And this comes in the movement. So if you go here to move MagicMirror, which is another class which we initialize here, MagicMirror joint mover. Then when we initialize it, it publishes into each of the commands that move the 4 joints of this robot, which is the mouth and these roll, pitch, and yaw to move the face around. So once we have it, then we wait for the publishes. This is really important because we have to be precise. It's not something that you publish it like a flux of data and then it will catch up. We can't afford that. So we need that when we publish mouth in this position, it has to go there. Because maybe in the next publish, it will be different. So all the topics have to be ready. For that, we use this function that I've made, which waits for all the publishers to have connections, more than one connection, and when it has, then it starts. This allows us to guarantee that when we do this init pose, which puts everything to 0, then it moves around. So it does it every time that we send it. Yep. Okay. So now, once we have the robot like working, so if we can go to ROS Magic Mirror description scripts Python move MagicMirror. Yeah, done. So as you can see, it closed, it closed the mouth and has everything to 0. So now I just executed this script, which what it does is initialize this one, which because you initialize this class, it just puts everything to 0. Okay. Okay, then we go to the distance. We subscribe to the mouth open distance and also to the head pose, which if you remember in previous videos, if not, please go to that video that I'll link here somewhere. Then this one publishes roll, pitch, and yaw, well, X, Y, and Z, we'll see that it's not exactly the same. So we'll talk about that in a next video. But basically, we have it already. And this is the one that we talked about in this video, how to generate it. Once we have it, we have the publisher, then in this callbacks, we do the moving. So in the mouth open distance callback, we'll move the mouth. So for that, we get the message, which is just a float. And what we do is interpolate between the maximum and minimum that more or less we've seen that the distance when we in the videos and in the video data, and when we get that distance, what that distance normally oscillates between, which is around 0.22 and 0.72, more or less. So I've just interpolated between those values and the maximum and minimum of the mechanical mouth, let's say the mouth of this simulation, the MagicMirror. This guarantees that I don't, for example, normally, like this is closed. This means that in our simulation, it would be open, because open means 0.1 maximum. So we need to interpolate to get that movement proportional to the movement, the real movement of the mouth. Okay? So this was like a tiny, tricky part. Nothing very fancy. And then once we have the interpolation, which we are using here with NumPy, very handy, and we send that to the mouth move mouth joint, which is if we go here, you just publish the angle given. Okay, yeah, and that's it. Just the callback of the head post, the same thing. We read it, we get the X, Y, and Z that are published there, and then we send it to the move head joints, which moves the roll, pitch, and yaw joints. And that's quite it. So the last thing I want to show you is, okay, and how do I do this? How do I test it? Well, I've done this move mouth demo, which launches three things. Launches the ROS Face Landmark Detection Publisher, which publishes does all the work, and in there it also publishes so this gets all the data from the images, and then generates all the markers. Okay, this we talked about in previous videos. And this one, the read face landmarks move mirror, is the one that we talked about, which is, let me just refresh, which is this one, which calculated the mouth distance, it published that. Yeah, basically that's what we are doing. And this ROSBag, which in theory, like in reality, we would just read from a camera that we have plugged into RaspBerryPi or I don't know what. But for this to test it very fast, it's very good to have ROSBags, because I just have a feed of images all the time, looped. As you can see, I loop the images all the time, so I can see the performance and I don't have to stare at the camera all the time to do my tests. Yeah. So if we launch this, let's have a look. So ROS launch, MagicMirror, move, mouth. Okay. As you can see, it's the output of all. So until we don't have publishing, you see, now we have data. So if we go here, we see that we are doing the tracking, and we see that the face is moving. The mouth also, and it more or less, let me just put it here. Right. Yeah, and this, sorry. This, I'll put it here. Yeah, so it just, so you can see that it doesn't track perfectly, but it gets the opening of the mouth and the movement of the head. It's the axes are different, so we'll see that in the next video. But basically we have, you see here that it turns, and I turn my head left and right and it goes up and down. It's just changing the axis. But we'll talk about that in the next video. And that's it. So it was a fast video. I hope you liked it. If you liked it, please leave a thumbs up, and please consider subscribing, because we publish videos every day about ROS and other related topics. And please check out any of our courses about this if you want to learn more about creating your own robot simulations or working with ROS. Please check out in RobotIgniteAcademy.com. And if you want to develop in ROS Development Studio, you just have to create your account and start working. So thanks a lot, and see you in the next video. Bye.